Right, okay. These hyperbolic functions. Basically, our first topic is FP3, the hyperbolic functions. So in these hyperbolic functions, we are learning some kind of a different trigonometric relationships that is called sin x, cos x, tan x, sec x, cos x, and cot x. So these are the basic trigonometric relationships where we should learn, right? Initially, what we need to learn here is that sin x, right? Sin x relationship is because it's a hyperbolic functions. They are with that you can say sin x as ex minus e to the power minus x divided by 2. Right? This is the basic relationship if you want to get it. Minus e to the power minus x divided by 2. This is the formula for sin x. The next one is cos x. Just this is similar to sin x, cos x, tan x, cos x. Cos x is the same thing, only a addition comes in between. So that is e to the power x plus e to the power minus x divided by 2. Then I think you can remember there was a relationship tan x. Similarly, you can say tan x. Tan x is equals to sin x divided by cos x. Therefore, this is turned up to, then you can say this is tan x, not tan x, tan x, turn up to sin x divided by cos x, turn up to e to the power x minus e to the power minus x divided by e to the power x plus e to the power minus x. Just divide this one by this one. Right? That's a next relationship where we should know. Right? Okay. Then the next fact where we need to learn is the cosec x. This bit. So over here, it's just like this. Cosec x is equals to, so you can say the same relationship. There is no much difference between the theories where we have already learned in sin x. So this is the fact 1 over sine. We know that cosec x is equals to 1 over sine x. So that cosec x equals to 1 over sin x. That is turned up to 2 over the reciprocal of this. E to the power x minus e to the power minus x. Just I think you already work over here, but that's how it comes with it. Then similarly you can work out sec x. Sec x is equals to 1 over cos x. That is, so you can say sec x is equals to 2 over e to the power x plus e to the power minus x, right? The third fact where we have to learn here is the cot x. Cot x is equals to 1 over tan x, or other than that you can say cos x divided by sin x. Hope you can understand how I'm getting these ones. So basically then you can say cot x. Cot x is equals to the reciprocal of this. So you can say e to the power x plus e to the power minus x divided by e to the power x minus e to the power minus x. That would be the answer for tan x, sin x, cos x, cot x, and we should know these relationships. Okay. Now that is the first fact we need to learn about how to get these hyperbolic functions, right? For example, if you need to find these figures, right? For example, we want to suppose that we need to find sin 3. If you want to find sin 3, we used to use this equation. From this equation, you can get this answer, this part of it. So you can say e to the power 3 minus e to the power minus 3 divided by 2. So if you want, you can do a further simplification. 1 over 2 e to the power 3 minus, this is 1 over e to the power 3. Then you can say 1 over 2. This is, if you take the LCM, e to the power 3 into e to the power 3, turn up to e to the power 2 into 3, that is e to the power 6 minus 1 divided by e to the power 3. So that's the answer for Shin 3. That's how it comes, right? Okay, when you are working out with this, there is no need of working with whether it's like, what do you call that, whether it's in radian or degree doesn't make difference for this hyperbolic function. So similarly, you can get any kind of facts where we need to find it. Right? Okay. Yeah, so you can, if you want to get the other one, if you want to get tan 1, tan 1 is, you can say e to the power 1 minus e to the power minus 1 divided by e to the power 1 plus e to the power minus 1. That is turn up to, so if you want, you can simplify. Yeah, there's another simplification over here, but that's it. Later on, we'll just to code it. This is e to the power 1 minus 1 over e to the power 1 divided by e to the power 1 plus 1 over e to the power 1. So if you take the LCM over here, this is turned up to e to the power 1 into e to the power 1 is e to the power 2 minus 1 divided by e to the power 1 get cancels, e to the power 2 plus 1. If you want, you can write in this format. After that, you can put in the calculator and you can obtain the answer for this particular. Then if we happen to see this kind of situation, this is just like another approach. If you want to find tan ln 4. So if you want to find tan ln 4. Tan ln 4. According to this relationship, so you can say e to the power ln 4 minus e to the power minus ln 4 divided by e to the power ln 4 plus e to the power minus ln 4. Right. Then we know that e to the power ln 4, you can simplify, that is turn up to how much? E to the power ln 4 become 4. Minus this part. How to operate this, and I'll use a different color to explain that situation. If you want to get e to the power minus ln 4, so I just take this
minus 1 over 4.
So turn up to e to the power ln 4 to the power minus 1 is 1 over 4. E and ln get cancels, turn up and turn up to 1 over 4. That's pretty simple. It's 1 over 4 divided by 4 plus 1 over 4. So that is turn up to 15 over 17. If you just simplify this, you'll be receiving the answer like that. That's a way of getting this answer. Hope you can understand this section. Right. Okay. Then, yeah. Then they want to work out, use the definition of Shin x to 2 decimal places the value for x. Shin x equals to 5. How to solve this equation? So they ask how to solve Shin x equals to 5. So from your calculator, even you can get Shin inverse. But manually we should be able to solve this equation. So if you go to the Shin relationship, this is e to the power x minus e to the power minus x divided by 2. Yeah, e to the power x minus e to the power minus x divided by 2 is equals to 5. Then you can say e to the power x minus e to the power minus x is equals to, if you cross multiply, turn up to 10. Right. Then we need to form some kind of a equation just like this. We can say this is e to the power x minus 1 over e to the power x is equals to 10. Then if you multiply everything with e to the power x, this turn up to e to the power x whole thing squared minus 1 is equals to 10 times of e to the power x. Then we can say if you get this e to the power x as a constant, k, you can say k squared minus 1 is equals to 10k. Then you can say k squared minus 10k plus 1, sorry, minus 1, it's not plus 1. Minus 1 equals to 0. So with this information, you can say k is equals to minus 10 plus or minus b squared minus 10 squared minus 4a is 1, it's minus 1, the square root of it, divided by 2a, divided by 2 into 1. So therefore k is equals to 10 plus or minus 100 plus 4 is 104. 104 is 2 root 26. 6. 52, yeah, 26 divided by 2. So k turn up into 5 plus root 26 is the one solution. Other one is k equals to 5 minus root 26. Then this is e to the power x. So you can say e to the power x is equals to 5 plus root 26. Then other one is e to the power x is equals to 5 minus root 26. That's how it comes. Right. Then, yeah, that's how it comes. So we know that this is a value which is greater than, less than 1. So this value is smaller than 1, so it does not exist. This is does not exist because e to the power x, if you just draw the e to the power x graph, it's a positive graph. But here the value, if you just work out, you can say it's a negative value. So e to the power x is greater than 0. So this does not exist. So the answer becomes x is equals to ln 5 plus root 26. That is the answer for that. Because if you bring this e to other side, turn up to ln, you can write it's 5 plus root 26. That's a way of getting this answer. Hope you can understand.
So you told that we can directly take inverse of shin x, no? How,
Yeah.
sir, can we do that?
So you can go
From the
to
cal?
take your calculator. In your calculator, there's a button called hyper. Just check whether the hype. There's a button called hype.
No, sir.
One second.
Next to sign.
Next to sign.
Yes, 1 second. I'll just go to my calculator. And
So the white cal?
Whatever the calculator, same thing. So you can say it's next to sign button. Just see with the prior to sign button, there's a button called hype. Prior to sign button?
No, sir, I don't have.
But then what is the button before sign?
X to the power minus 1.
Prior to that, just 1 second with it. Then yes, that's it. So you can just put you can say shin inverse. If you just put shin inverse of 5, also you get the same answer, 2.3124, which is literally similar to this answer. Yeah, ln 5 plus 2 root 6. Five plus root 26, 2.31. This is long, right? Okay, that's right. Yeah, right, okay. So this is going to put a bracket over here. So that's the answer what you need to get with it. Then over here, so you can get these facts, not a problem over here. Use the calculator to find the 3 decimal values for shin 4, cos half, tan minus 2, sec 5. So what you need to do is for this question, even you have to, though you mentioned use a calculator, you have to do it manually and see whether these answers are correct. So shin 4, if you want to put it, you just put e to the power 4 minus e to the power minus 4 divided by 2, and you can get this answer, right? Okay. Then write in terms of e shin 1. Write in terms of e shin 1. So you can say exercise 1A. Question number 2. In terms of e, they need to find the answer for shin 1. Shin 1, you can say e to the power 1 minus 1, e to the power minus 1 divided by 2. So you can say, if you want, you can write e to the power 1 minus 1 over e to the power 1. You can take this half out. So if you take the LCM, 1 over 2, if you take LCM, e to the power 2 minus 1, or just like divide by 2e. If you want, you can write in this format of the answer. Right? That's how you need to do this, all these questions, right? Then find the exact value of shin ln 2. Shin ln 2. Ln 2, right? So you can say this is e to the power ln 2 minus e to the power minus ln 2 divided by 2. So you can say this is, if you take 1 over 2 out, ln 2 is 2 minus this is e to the power minus ln 2 is 1 over 2. Yeah, minus 1 over 2, it's ln 2. So you get the answer 2 minus half is 3 over 2, 3 over 4. So simply you can get this answer for that. That's a way of doing this kind of situation. So with our command turn ln 2 also, same thing you can do it. I think we did one question similar to turn. Yeah, turn ln 4, we did the same way. You can just try with turn ln 2, right? Okay. Yes. Then we'll come up to these important questions over here. That is, if you want to solve cos x equals to 2, cos x equals to 2. So question number 4. I think it's question number 4. Yeah, cos x equals to 2. So you can say, I'll just use a different new page. Cos x equals to 2. That is turn up to e to the power x plus e to the power minus x divided by 2 is equals to 2. So you need to find the exact solution to it. Therefore, you cannot use a calculator for this. Equals to 4. I just cross multiply here and then take this one here. Then this is turn up to e to the power x. If you take the LCM, 2 plus 1 is equals to 4 times of e to the power x. I just, and then you can multiply everything with e to the power x. Then I'll get e to the power x as k. So it's turn up to k squared plus 1 equals to 4k. Then k squared minus 4k plus 1 is equals to 0. So with that you can write k is equals to minus 4 is plus 4 plus or minus b squared minus 4 squared. 16 minus 4a is 1, c is 1, divide by 2a. 2 into 1. So it's turned up to k is equals to 4 plus or minus square root of 12 divided by 2. So that answer is k is equals to 4 plus or minus 2 root 3 divided by 2. So k become 4 plus, sorry, if you divide both sides by 2, so it's turn up to 2 plus root 3 is a one solution. Other one is k equals to 2 minus root 3. So over here, but both answers are applicable because, so if you get e to the power x is 2 plus root 3, other one is e to the power x is equals to 2 minus root 3. So both can be, it's possible. So you can say x is equals to ln 2 plus root 3, other one is e to the power, sorry, e to the power x is equals to, sorry, x is equals to ln 2 minus root 3. So you can get these answers over here. That's a way of doing this kind of a question. So like that you can do all of these questions in the similar technique. So you can get this answer for that. Then we should know how to draw the hyperbolic functions. I'll use a new page for that. Hyperbolic functions, right? Okay. So in this case, what you can understand is this point. So if you want to get Shin x graph, Shin x. So you know that Shin x equation is e to the power x minus e to the power minus x divided by 2. Right. Okay. Then initially, if I want to draw, I just draw e to the power x graph separately. So in this, sorry, not separately, the same diagram. If I draw e to the power x graph is like this. Sorry, that is the other, sorry, e to the power x graph is like this. This is e to the power x graph and this is e to the power minus x graph. E to the power minus x graph. Then what you can understand here is, here the value is 1 and 1, 2. So if you come up over here, this end, this value is 0 and this value is infinity. Therefore, this value written as infinite. Here the value is 1. Both values are 1. So it's turned up to 2. 1 and 1 turn up to 2. Here also it goes to infinity. Therefore, you can draw e to the power hyperbolic e to the power x function. Sorry, yeah. Then this is e to the power minus x. So, sorry, it's not addition of these two, it's a subtraction.
So it's subtraction,
Yeah,
no?
subtraction, sorry. So, make it there, you have to draw e to the power minus x graph. I just made a mistake. I'll just erase this bit of it. This is not relevant. Make on after. Because we need to draw e to the power minus x graph. You have to draw it from the beginning. Then this is the way of e to the power x graph. Then e to the power minus x graph is like this. Then it's turned up to negative part of it. So it's turned up to from -1. The graph goes like this way around. So in this case, what you can understand is here the final answer should be turned up to how much? If I just use the blue color for that. This is e to the power minus x graph. Minus e to the power minus x graph, sorry. Minus e to the power minus x graph. So over here, if you just operate this is 0 and this is infinity, therefore it's turn up to minus infinity. Plus 1 and minus 1 turn up to 0, and this is 0 and this is infinity, turn up to infinite. Therefore the graph become somewhere shaped like this. It's gone like something similar to our x cube graph. Something for that. So that is a graph of Shin-X graph. So you can say it goes like this way around.
So we can also draw the e to the power x and e to the power minus x, then get the resultant. That's also same, no?
Yeah, that's it. Yes. That's almost the same thing. You can do it with it. Okay, like this kind of a graph you can see. Okay. Then let's go to the next graph today. That is turn up to cos x graph. I think that is a graph I was drawing at the beginning. Cos x is equals to e to the power x plus e to the power minus x divided by 2. Just it's over here. This is a graph. Yeah. Then over here. If you draw e to the power x graph is like this. Then e to the power minus x graph is this way around. It's 1. E to the power minus x. So here the value is 0 plus infinity divided by 2. So it starts just like somewhere over here. It infinity divided by 2 also just like infinity. Right. This is 1 plus 1, 2. 2 divided by 1 is 1. Here also the same thing. It's just like this. Therefore, you can see some kind of a similar cos x graph would be somewhere like this. The blue black color one, which is already drawn here, but here it's a blue color. I just draw it. So you can see it's a shape like this. So that is a cos x graph. Right. Then the next part where we need to know is the how to draw this tan x graph. This is kind of a complex situation, Shin x over cos x, and you have to do a little bit of it, but roughly we should know this shape of the graph. That is the only requirement of learning this topic. So just having a slight idea, it's vary from +1 to -1. That graph is learning is enough when you are working out with this tan x graph. No need of working out with all of these segments. So that is not much relevant in our curriculum. Then if you draw this sech x graph, sech x graph is 1 over tan x graph. So initially we'll just draw this one. So you know that with a sech x graph. So sech x graph is, you know that it's 1 over cos x. That means put over here, what you can understand is, if you just draw this is infinity. 1 divided by infinity is how much? Turn up to almost 0. This is 1. 1 divided by 1 become 1. Again, also infinity is turned up to infinity. Therefore, you can see the graph somewhere like this. Just like our normal distribution or just like a bell-shaped graph, you can see a shape somewhere like this for cos-x, just like what we already drawn over here. Then Shin X graph, sorry, just this much. This is sorry, this is cos Hx graph. That is equals to 1 over Shin X graph. Then if you just work out, you can see this is negative infinity. This is negative infinity. 1 divided by negative infinity is negative 0. Negative 0 means somewhere over here. Okay, so here this is turned up to what you can understand is this is basic shape. If I just work out the basic shape, then you can get the idea on that. Then you will understand how it comes. Sorry, it's like this. Then this is 1 divided by negative 0. 1 divided by here, this is negative 0. That is turned up to negative infinity. Here, 1 divided by plus infinity is plus 0. 1 divided by plus infinity is turned up to plus 0 is equal to plus infinity. Therefore, you can see this Shin X graph somewhere like this. That's the basic shape. Sorry, it's like this. That's a basic Shin X graph where we should know. So those are the basic, we should know how to handle this kind of a basic trigonometric graphs. That is the requirement over here. So like that, if you want to draw the cot X graph also, you have to consider like this. So it was just draw the tan X graph and then you do the cot X graph. Tan X graph is like this way around. It varying from +1 to -1. So we already learned it's just like this. In a previous diagram, we just went through it once infinity. So you can say cot X graph is just like this. It's turn up to this is 1. So at infinite value, 1 divided by 1 is 1. So cot X is 1 over tan X. You have to get this idea. Right. Over here, it's 1 divided by -1 is -1. It's -1 over here. This is turn up to 1 divided by negative infinity. Negative infinity means it's come up, sorry, negative 0, that is negative plus infinity. So the graph goes like this way around. Here, yeah, you can see there's a graph over here. It's traveling from +1 and -1, +1 and -1, and over here it's turned up to minus infinity, just like this. Because here it's 1 divided by negative 0 is negative infinity. So this is the basic shape of the graph. So it's already drawn over here. There are two axes of asymptotes, +1 and -1. That is the basic shape of the trigonometric graphs where we should know when you are learning this kind of a concepts. Right, okay. Then, yes.